Hello everyone and thank you for joining. My name is Brittany and I want to welcome you all to the Windows 10 Security Improvements webinar. First we'll talk about a couple optimization tools, then I'll introduce our speaker Charlie Hill and he'll take over and give his presentation. We'll also talk about Quick Start and show some of our Windows 10 courses and other training options we provide, and we'll have Q&A for any questions you might have for Charlie. This webinar is being recorded and will be available to you by Tuesday. Please email me at brittany.morin@quickstart.com if you have not yet received that by Tuesday. And then to optimize your experience during this webinar, feel free to ask questions by clicking on the message icon and typing it into the box at the bottom left. If Charlie does see that he can answer your question without going too off topic, he'll answer it. Otherwise, he'll wait till the end during Q&A. And if you don't want to see the chat section, go ahead and click the X at the top of the message box. I'll now hand it over to Charlie and he'll give his presentation. Charlie?
Good morning, this is Charlie. Can you hear me?
Awesome, we can hear you.
All right, and you should see my screen firing up here in just a second.
Okay. We can see it.
Excellent. Good morning, everybody. My name is Charlie Hill. I'm a network security engineer. I've been working on networks for a little over 30 years now. Started as an early adopter on Commodore 64s and VIC-20s and worked my way up to programming on mainframes with punch cards, but I am no longer a programmer. I now specialize in security and virtualization, two fields that seem to have converged quite a bit in the last couple of years. What we're going to do now, we're going to take a look at Windows 10. We're going to look at the new security features that have been implemented in Windows 10 and how they address some of the changing needs that we've got. Windows 10, the latest in a relatively long lineup of operating systems, introduces quite a few changes, and many of these changes are not noticeable. There are quite a few that we'll see patently on the surface, and here in just a second I'll show you a couple of them. But many of the new features that really make this a desirable business place operating system are not necessarily visible on the surface. One of those is the fact that it's a consolidated platform now. What I mean by this is it's the same platform for phones, laptops, tablets, desktops, and even servers. It's more than just the same platform, it's actually some of the same kernel code. What this means is it's going to simplify supporting applications across your devices, something that right now presents a lot of IT departments with a significant challenge. We'll also look at application control, which basically means keeping your users from doing things they're not supposed to do software-wise. We can all think of programs we find running on our users' computers that really shouldn't be running on our users' computers, but the tools we have available to prevent them from doing so are limited in their capabilities. We've got some new ones that I think you'll find quite effective. When the mobile world really started taking off and the devices that we carried around started becoming more and more feature rich, the devices themselves started to pose a threat. For example, taking a phone with a camera into a place with top secret product and top secret intellectual property is a hazard. You could take pictures and then leave with that phone and you just stole their information. So the need to control the way these mobile devices operate in different environments is an evolving one, and it's one many of you have probably already encountered, especially if you have any Department of Defense contracts. Several DoD contracts will actually have clauses that specify that if working on, for example, a secure base, you're not allowed to have a phone that has Wi-Fi, removable media, Bluetooth, or a camera. I wonder where you would even find a phone in today's marketplace that didn't have those things. There actually are a few, but they're kind of hard to come by. And if that's your only phone, then it means you don't get those features when you're in other places. So the ability to turn these features on and off is another very desirable feature. Then there's Device Guard. This is one of the more robust features in Windows 10. Device Guard is actually going to control the code that can be run on a machine. This includes not just undesirable malware, but also your ability to control what versions of software you're willing to let your users have. You can support the version that passed testing and prohibit the versions that you know cause issues for yourself. The Device Guard also protects against code being modified, which is the principal means of malware spreading. And I'll take a look here in a few minutes and show you how each one of these things does what it does. Let's look at the Consolidated Operating System Platform first. This has been a challenge as long as we've been using computers. How do we keep the software that we support viable if we're constantly changing our operating systems? Here's a quick current report of operating system penetration for desktops. And we can see Windows 7 at well over half. And XP still has twice the market share that Windows 10 does. This is going to change quite a bit over the next quarter. But this reflects the fact that XP still has over 12%. It's better than 1 out of 10 computers out there still running XP. Reflects how desirable an operating system that is proven is. Even if we know it's got flaws, it's still quite persistent. I've got customers that are staying on Windows 7 because going to Windows 8 presented them with too many technical difficulties. It was too much of a change. There's quite a bit of pent-up demand for going to the new operating system, as Windows 7 is relatively old by operating system standards. Now, these are desktops. If we take a look at this exact same report on mobile devices, you see a radically different number. Almost the exact amount of market share held by Microsoft for desktops is held by Android for tablets. In fact, Windows represents less than 3% of the tablet and mobile device operating systems that are out there, which means if you're a company that's supporting mobile devices and desktop devices, this guarantees that you're going to have two different platforms you have to troubleshoot because of how very different the operating system profiles between mobile devices and desktop devices are. This means every product has to be tested in both environments. Every patch has to be tested in both environments. Your backup, recovery, and control methodologies are all complicated by the fact that it's inconsistent here. Well, with Windows 10, Microsoft is pushing forward their one Windows approach, where the desktop operating system, laptop, tablet, and phone all have the same kernel. And with the evolution of the cloud, when a user logs into any one of these devices, this is not the default behavior, but this is configurable behavior. You can have the files, apps, and settings that help that user do what that user needs to do, follow them around, no matter which of these devices they log into. As the cloud gets more and more universally available, the thing in your hands becomes less and less relevant every day. The computation is not happening on that device, not for things like Cortana or Siri. Your files often are not stored on the device, not if you've got them available in the cloud. So what's happening is we are abstracting where the data is and where the programs are from the experience that the user has. Once we finish this transition, the little piece of glass that you hold in your hand will be of very little relevance to the configuration and control. Everything will be done through software and through cloud controls. Let's start with application control. One of the biggest problems that networks that are still supporting XP face is that XP's software stack is inherently insecure. There were things that we supported back then that we don't support anymore. And if you've got any of those XP environments, then you probably are familiar with what I'm talking about. You've probably got a program or two that users can install on XP, and you really wish that they wouldn't. Shopping Buddy, Bonsai, WeatherBug, you could probably think of a few of these. Well, we've got some tools that will help us keep people from running programs that we don't want, but each of these tools comes with its own set of issues. Another thing that we need to worry about with applications is license compliance. If you have 500 users and you buy 500 licenses for a program and install that program on 500 computers, you have used all of your licenses. If you leased those computers and the lease is up and you send those computers back and get 500 new ones, when you try to install it, you will often run into a problem where it says you're out of licenses. So you need to reclaim the licenses from the machines that are no longer using the software. So this is another aspect of controlling applications that we've needed for a while. Some of the tools we have available to us include software restriction policies. Software restriction policies, which are implemented usually through a group policy, they've been around for a while, And they work in a few circumstances, but they're pretty limited. They cannot, I cannot control what actual code a person runs with a software restriction policy unless I'm actually identifying the code itself. Let me show you what I'm talking about by pulling up a Windows 10 machine right now. I'm going to run the Local Security Authority tool, which I think I've already got listed here. There it is, Local Security Policy. Local security policies exist on each machine. We usually don't manipulate them at each machine. Instead, what we'll do is we'll manipulate them through a group policy so that everybody experiences the same thing, if that's your intention. So if we look here at software restriction policies, which are still supported in Windows 10, I'm going to create a software restriction policy just to show you what they look like. I'll create a rule, and here's one of the problems that we have. There's only 4 types of rules, 4 ways to identify the programs. I could identify it by path. The problem with path is all a user has to do is move the file and it's no longer in that path. They don't even have to move it. They could just rename it. So you could use a certificate rule. Certificate rule refers to who authored the program. And you can say, oh, I only want to run programs authored by our approved authors. The problem with certificate rules is that until very recently, most applications were not signed, so we could not verify the point of origin unless it was a program we built in-house. So that was limiting. You could use a network zone rule, but network zone rules are only referring to the applications run through a web application, and it's referring to the zones identified in Internet Explorer, such as intranet, trusted security sites, or untrusted. So any application that wasn't being run from a web application or a website wouldn't be affected by this rule anyway. The most conclusive one was this one here, a hash rule, because a hash rule identifies the actual hash value of the file. You can move a file, you can rename it, you can put it anywhere you want, and that does not change the hash value. But if somebody injects malicious code, if you change the contents of a file, you do change the hash value. So these were the 4 options that we had with software restriction policies. The big problem with the best bet here, the hash rule, is that I could identify a program I wanted you to run or wanted you to not run by its hash. You could move that file, you could rename it, and if I didn't want you running it, you still can't run it. As a matter of fact, the only thing that would cause it to not match a hash rule would be if the contents of the file changed. Unfortunately, or rather fortunately, there is a legitimate activity that does exactly that, and it's typically every second Tuesday. Updates to code will change the content. That will in turn render the hash rule ineffective, because all you have to do is change a single bit in a file and it gets a radically different hash value. So these were the options we had with software restriction policies. They were limited, and they were approved upon by AppLocker, another capability that was introduced several operating systems ago. AppLocker works on principles similar to software restriction policies. The difference is that with the rules in AppLocker, I could create a rule and identify the application I wanted you to run, either allowing it or denying it, and for individuals, so I can give different people different capabilities. Then I identify the condition. We have file hash, which is exactly like it was with software restriction policies, and path value, again, just like it was with software restriction policies. But it's the publisher rule that made it easier for us. Because now what I could do with the publisher is I could go to a file, and I'm going to pick one here that's kind of a silly example, but it's just to illustrate this concept. I'm going to go to Windows System 32, and I'm going to identify an incredibly dangerous application that's probably caused numerous problems for you in the workplace. Calculator. Okay, clearly not a really bad program, but I'm just using this one as an example of what the AppLocker rules did for us that were an improvement. As you can see here, this rule is currently saying that calc.exe, as you see listed there in the name of the file, version 10.0.0.0 and above, as it says just to the right of it, that those cannot be run. But with this slider bar here, I can change that, and I can say, you know what? Any version of calculator could not be run. Or I could say anything from this product could not be run, or anything from this publisher could not be run. Now, I wouldn't do that here because this publisher is Microsoft, and that would basically render the operating system unusable. But this is an example of how AppLocker improved what we had over software restriction policies, but it still came up short. Now we have a new capability called Device Guard. Device Guard is going to verify the code, but it's up to us to specify which code is approved and which code is not. So if there's new versions of software, we would have to reflect that the new version is supported. For mobile devices, this is largely controlled through Windows Intune, which is Microsoft's Mobile Device Management, or MDM solution. If you're using Windows Intune, you get to leverage a lot of these controls across mobile devices. It also includes a company application portal, which allows you to provide a means for users to add software. Now, within Windows, there is the Windows Application Store. That's this thing right here. That's the Windows App Store. This store is where you would go to find applications offered by Microsoft or any vendors that publish their application through the Microsoft Store. These are third-party commercially available applications like the great Farmville. You can create a company portal, which includes applications that you want your users to be able to run, including specific versions and controls, and provide a whole nother way of getting applications onto these devices that works very much like the Microsoft Store, but is completely independent and is yours to control. That's going to make a big difference as we start to deploy more and more applications to these mobile users. Feature control, what your phone or tablet or laptop can do. As I mentioned before, in some high security environments, disabling features is not just something you want to do, it may be something you are legally obligated to do per the terms of your contract. Again, this is especially true for DoD, Defense Department, but it's also true for financial services, legal services, the medical industry, aviation industry, automobile safety. So you don't have to be a DoD contractor to be subject to DoD level security implementation. To control the devices, we've had group policies available for us for a while that can control certain capabilities of hardware. This uses Active Directory. We've been doing this for a really long time, and while it is inherently something that can cause frustration, most organizations have worked their way through those growing pains and have gotten group policies to do what they want them to do. But there's a problem with group policies. Group policies only affect Windows devices. So if you're trying to control something that's not a Windows device, then group policies are not really going to do anything for you. And because of BYOD, or bring your own device, and how very, very popular it is in the industry today, many of the devices you'll be controlling are not going to be Windows devices. But there is a Windows product that can help you. Windows Intune, again, Microsoft's mobile device management platform, and it's an enterprise class tool. What enterprise means is instead of referring to individual networks in your business, enterprise refers to all of the networks and all of the IT necessary to keep your business running. Intune is not for managing individual machines, although it does have that capability. This is a big picture tool. This is for managing lots of machines in as automated a way as you can. Windows Intune is Active Directory integrated, and if you're using Windows devices, it leverages that integration and optimizes very well. But it's not limited to this. It actually will control other devices, including Android and iOS. In order for this to work, you have to get a file from the vendor of the device. This file tells Intune what capabilities the device has and how to control it. So with Intune, if I'm an Active Directory Microsoft-centric environment, but my employees have purchased Android and Apple phones that they want to connect, I can connect them and I can control them. This control extends beyond just turning their applications on and off. I can remotely wipe files, user data, and potentially even blank out the entire phone if that's the appropriate course of action. So Intune's Microsoft's entry into the cross-platform mobile device management. Right now, the industry is going through a bit of floundering. Ever since BlackBerry lost their spot at the top perch for enterprise communications, the industry has been lacking a clear solution. And in that void, several ideas have popped up, but none of them have really taken off. There's AirWatch, there's Google's Divide, and Microsoft's Intune. But at this point, it's still an arm wrestling match. We don't have a clear winner. Device Guard. Now we're looking at controlling what's actually running on that laptop, tablet, or mobile phone. This also works for desktops. And while we can do it on desktops, we tend to do this kind of control more on mobile devices because of the vulnerabilities that they present. It's a lot easier to steal a mobile device. They go to places we don't have control over, and they're subject to conditions that we don't know and we cannot control. So with Device Guard, what we're going to do is we're going to control what's running on these devices, but we're going to do it by verifying code. This requires that you have a few things in place before you can do this. I'll go over what those requirements are in just a minute. It's leveraging virtualization to control what does and does not run on your machine. Built into Windows 10 is Hyper-V. You can run virtual machines on a Windows 10 computer as long as you meet the minimum requirements without having to install anything else. You just have to build the additional virtual machines. The way Device Guard prevents software from running on your computer is by verifying the signature of that software. That's similar to what we could do with AppLocker, only one of the big differences is that with AppLocker, that slider bar that I showed you that allowed me to control what applications could and could not be run, that slider bar only let me pick from publishers that had published themselves to Microsoft. In other words, I could only use signed applications that had been signed by the vendor. If you have in-house developed software or really old software that is critical to your operation, we like the word legacy for that because it makes it sound fancy. If you have some of this legacy software, you can still control whether or not it is run and whether or not it is run after modifications by signing your own packages. You can sign any package. It doesn't even have to be one that you wrote. But with the package inspector tool, you can package an application and sign it. So let's say you do have one of those third-party programs. It's been around for a long time and you're happy with it, but it was not signed by the publisher. You can create your own signature and then require that signature in order to run that program. But there's a little more going on here. The signatures, there's a little bit more going on. Let's take a look at how this thing works. How is this protecting what's running on a virtual machine or a physical machine? I'm going to show you this on a virtual machine, but it behaves the same way for a physical computer. First, it starts when the computer starts. When you first turn on a computer, the operating system is not in control. The BIOS is. BIOS, which stands for Basic Internal Operating System or Binary Input-Output System. It's an old acronym. There's a little bit of debate. BIOS, which has included the firmware that is running your computer for probably the last 25 or 30 years, BIOS was created at a time when we were not worried about malicious code. There is no verification of what happens in BIOS. There is a replacement for BIOS. It's called the Universal Extensible Firmware Interface, or UEFI. With UEFI, you can implement secure boot. What that means is the software that is effectively the BIOS, although we call it UEFI now, that software has a signature. And if anybody tries to change that software, such as installing a rootkit before the operating system, it won't work. The machine actually won't boot. If it detects that the UEFI has been modified, as for example, if malicious code has been injected, it won't even boot the machine. This tells you this machine has been corrupted and it can't even be protected because the corruption lies below the operating system. After the BIOS, what happens next kind of depends a little bit on whether we're talking about physical or virtual machines. Windows 10 leverages virtualization. Even if you're not running a virtual machine, you're just running Windows 10, it's using virtualization internally. There's KMCI and UMCI. Let me explain what those are. KMCI, kernel mode code integrity, is talking about the kernel that is the core point of the operating system itself. Before the operating system is allowed to load, it is first validated. The kernel mode code is verified. Malware likes to affect this part of the operating system because this part is loaded before your anti-malware is loaded. So if the malicious code can infect your kernel, then the damage is already done before the anti-malware software has a chance to fire up. If your anti-malware software could fire up before the malicious code could fire up, then it would probably be able to detect it. But if the malicious code fires up first, it can actually disable your anti-malware, leaving you vulnerable. Symmetric, McAfee, AVG, and Trend Micro have all been targeted by this type of an attack. That's kernel mode. I'm going to show you something here, and I'm going to pull up Paintbrush to illustrate this. Inside the operating system, and this is true for all NT-based operating systems, which includes everything that has NT in its name, including Windows 10, which doesn't have NT in its name. Well, all NT-based operating systems divide what's happening in the processor into two very distinct parts. There's user mode, and then there's kernel mode. There is a boundary, a hard line that exists between these two areas. Everything that you and I would run, say for example Photoshop, maybe Excel, or maybe you're going to run Doom to play some old first-person shooter games. Each one of these applications is isolated from the other applications. This is why if Doom were to crash while you were playing, it would take out Doom, but your other applications would continue to operate just fine because they are isolated from each other. But then there's this line here. None of these programs, running or not, is allowed to talk directly to hardware. Hardware's way down here. Right above the hardware is a special piece of software called the hardware abstraction layer. The hardware abstraction layer is like a device driver that communicates to your hardware. The actual device drivers communicate with the HAL to get to the devices themselves. And then down here, nestled in the middle of all of this, is your NTOS kernel.exe. This is the kernel part of the operating system. If an application were to crash up here, if one of these programs up here were to crash, usually it just kills that program and does nothing to the others. And in most cases, you don't even get a message telling you that something bad has happened. The only feedback you get is that that application stops responding. But if you get bad code, either malicious or simply corrupted or poorly written, if you get bad code down here, it's another story. If you get bad code down here, you can end up with much more damaging consequences. The most common one we all recognize is the classic blue screen of death, which, by the way, is not what Microsoft calls it. They call it a stop error. But blue screens of death only occur if something bad happens below this boundary down here in kernel mode. So the kernel mode code integrity engine is making sure that everything that is loaded down here is verified before it is loaded. It does the exact same thing for code up here. Before it loads an application into user mode, it's going to verify the code itself to make sure that that code has not been modified. That's kernel mode code integrity and user mode code integrity. Both of these evaluate the code prior to allowing it to run. If you have a trusted platform module, then a set of encryption and authentication keys are hidden inside that trusted platform module. This raises the security because it's a lot harder to falsify a signature if the signature was created using TPM, which is basically a smart card embedded into the motherboard of your computer. That isolates the certificates and keys, making them very, very difficult for a third party to get. This protects sensitive information, credentials, and certificates by keeping them basically in a little lockbox inside your computer. So by verifying the BIOS before the BIOS is allowed to run, verifying the kernel before it's allowed to run, and then verifying binaries before they're allowed to run, this does a significant amount to prevent unauthorized code from running on your machine. In order to do this device guard, which is a part of this controlling of what's happening on your machine, you have a couple of requirements. This currently only works with Windows 10 Enterprise. You have to have a machine that is not using a conventional BIOS, but is instead using UEFI, in particular 2.3.1, if you want to do the secure trusted boot. Let me show you what this means. So here's my Windows 10 virtual machine. If I look at the settings on this virtual machine, you'll see up here there's firmware. And because I'm running this, by the way, on a Windows 8 machine that has the local Hyper-V installed. Windows 8 also supports virtualization. And right here you see I've got it configured to enable secure boot. And that means that if there were any modifications to the firmware file, it's actually a file stored in this machine, if there were any modifications to it and it did not pass the integrity check, it would not boot. It would stop it right here. So in order to do that, you have to have UEFI 2.3.1 or later to do the trusted boot. Windows 10 is going to protect the internal assets by isolating them through virtualization. It prevents unpackaged applications from running, which means you got to deal with the packaged applications. So one of the reasons I'm not seeing a lot of Windows 10 deployed right now across enterprise desktops is that it's brand new, and that in the workplace we almost always have these legacy applications. I'm sure that nearly all of you have at least a few legacy applications you got to continue to support. If you want to implement these security features, you're going to have to sign those packages using the Package Inspector tool. When you sign a package, any modifications to that package negate the signature and you have to re-sign it, which means code that is frequently modified will become a bit of a maintenance issue for you. So let's look at how this virtualization is working, this code isolation or sandboxing. So with Hyper-V or virtualization, you've got several layers going on. Here, I'll use Paintbrush again to illustrate this. So if we're looking at, say, a classic virtualized server, you have the physical box, which is what this rectangle is going to represent. And that physical box has its operating system installed, and it has its resources. It's got its RAM, it's got its CPU, and it's got its drives. But then on this physical machine, we would run virtual machines. Each of these virtual machines would get their own amount of memory, their own amount of CPU, and their own amount of network and drives. These virtual machines cannot see each other unless we decide that they're supposed to and create a connection between them. Otherwise, they are completely isolated. This is the very nature of virtualization. Well, since virtualization is built into Windows 10, it's going to leverage this to isolate things. For example, it's going to isolate your credential store. This is where your usernames and passwords are. It's also going to isolate the logon process so that it cannot be eavesdropped by other applications. So Windows 10 uses virtualization to isolate aspects of the operating system the same way VMware or Hyper-V used virtualization to isolate two different virtual machines from each other. Only now, instead of it being different virtual machines, it's different code running on one machine. This is called sandboxing. This is not a new term. It's not a new idea. In fact, what I showed you between the difference of user and kernel mode is an example of sandboxing. By isolating the code, if it is bad code, we can keep it from reaching out and damaging other things that are running on your machine at the same time. So instances cannot cross-contaminate because they cannot even see each other. And this isn't done just with the operating system. This is baked into the firmware. This has to do with the way your BIOS behaves, which is why some of the requirements that you have to have include a BIOS that is capable of this type of activity. It's capable of this kind of a feature. So how do we get this? Well, we have to get these signatures to identify the code that we want to support. These signatures are a result of what's called a hash value. A hash value is an integrity checking mechanism. Let me show you an example of some hash values here. There we go. Here I've got two files. I've got my first hash file. There we go. And then I've got another file called the second hash file. And I want you to take a moment to spot the differences between them. So the only difference between these two files is the very last character. One ends in a question mark, the other one ends in an exclamation point. Well, a hash value is what you get when you run data, any kind of input, in this case these two files. You run them through an algorithm and you get a numerical output. These outputs are produced by hash algorithms. I've added a little program to my computer that lets me see file hashes for the files. This is an MD5 or Message Digest 5 hash. That alphanumerical string that you see there uniquely identifies this. Well, what I did is I took the hash values from these two files. Take a look at the differences, or rather the similarities here. The only difference between these two files was the very last character. And yet if you look at these two strings, there's only a few characters that are the same in both of these. All of these other characters are different. So a hash value tells us, hey, these files might look the same, but they are not. And with the hash level, I can tell not only are they not the same, but it's patently obvious that they're not the same. So it's going to use hash values to verify code. But we got a problem here. Because of the way signatures work, it is possible that somebody could falsify it. Let me show you what I'm talking about. Let's say, you know what, in order to explain hashes, I need to talk a little bit about encryption, about symmetrical and asymmetrical encryption. Encryption, which is not new and not unique to computers, encryption has been happening as long as we've been writing things down. There's pretty good reason to believe the second cave drawing was probably a coded message. The way encryption works is you take your data and you feed it into this thing called an algorithm. An algorithm is really just a formula. It's a mathematical formula. It's going to do something to the data. And what comes out the other side is referred to as ciphertext, or it's the encrypted data. Normally, what you would do to turn the ciphertext back into the original data is you simply reverse the process of the algorithm. One example of this is one algorithm might be letter equals letter plus 2, in which case the message data would actually be translated into, let's see, the D would be E and F, A would be as A, B, C, T would be T, U, V, and A would be a C. So that is data translated into letter equals letter plus 2. I just went up 2 letters of the alphabet. To reverse this and get the original data, you would simply take the ciphertext and feed it backwards through the algorithm. Take each one of these letters, go down 2 letters in the alphabet, and you get your original data. This is referred to as symmetrical encryption. Encryption means that you use one key to encrypt and to decrypt. This is the way much of the encryption that's out there behaves. One of the benefits of symmetrical encryption is its speed. It's a very fast way to encrypt and to decrypt, which is actually one of the main reasons we don't like it. Because all I would have to do is try all possible combinations with today's computers. That would only take a few seconds and I could decrypt this. which is why we have another form of encryption called asymmetrical encryption. Asymmetrical encryption, you have two keys, which basically equates to one to encrypt and one to decrypt. Although there's a little bit of wiggle room in that, as you'll see here in just a second. And then we have hashing, which is technically referred to as a one-way encryption. What they mean by one-way encryption is I showed you the hash values for these two files. If we looked at this hash value in here, this hash value is always the same length, no matter what size the file going into it is. So one of the things that can happen is there is no way to take this hash value and get the file that I used out of it. It doesn't work that way. That's not the purpose of hashing. Hashing is not a confidentiality algorithm. It's not trying to make your data secret. It's an integrity algorithm. It's trying to let you know if it's been changed. So here's the way that signatures work. So let's say we've got the code, the application. This is the application that you've tested and you've approved. And you said this application, application 1, I want everybody to be able to run. So here's what will happen. You're going to run the application using the package inspector tool. You'll take this application and you're going to generate a hash. This hash value is then going to be attached. If anybody were to modify this file, now let me grab a hash value just to have one for example's sake. Let's say that's the hash value. Well, now this application has a hash value on it. Every time that application is run, before it is run, device guard is going to look at the signature, the hash, and make sure that that's the hash the file still has. If the hash has been changed, then we know, there's bad code or some kind of change on this file. Well, here's the problem. Let's say I'm the bad guy and I want to do something bad to you. So I'm going to take this file and I'm going to inject some bad code into it. And when I do, the application now ends up with a radically different hash value. Well, you would be able to tell, hey, that's not the same hash value. Well, couldn't I just take this hash value and simply say, that's the hash value you're supposed to see. And now you can't tell that I've encrypted it, which is what would happen if this is how it behaved. But it's not. Because what we're going to do with this hash value is we're going to use asymmetrical encryption to hide it. So now I got to explain how asymmetrical encryption works. And I'm going to do paintbrush again, but I'm going to use an example you're probably personally familiar with. This is going to the web, surfing, maybe let's say your bank. So the way asymmetrical encryption, and what I'm using here is HTTPS as an example of this, but it's not limited to HTTPS. It behaves this way all over the place. We use asymmetrical encryption, public and private keys, a lot. So when you try to connect to your bank and you use HTTPS, indicating you want to have a secret conversation, your bank says, oh, I can do that. Because, and this has to happen before, your bank has to have a private and a public key that belongs to it. These keys are the keys that are going to be used to encrypt and decrypt. These are your asymmetrical keys. The private key is called private because you don't give it to anybody. The public key is called public because you give it to everybody. So this machine, this server, has a public and a private key pair already, and it's going to give you the server's public key. It's going to do this in a file. This file is called a certificate, something I'm sure you've seen before. A certificate contains the public key, also some other things like expiration date, because they're not good forever, and issuer, and that's a big one right there, the issuer. Probably the best known name for this is VeriSign, but there are lots of other vendors you can get a certificate from. The issuer has signed this certificate. They've got their encrypted hash right here on the certificate. This certificate is then sent to you. So when you're trying to have a conversation with your bank and you want it to be secret, your bank says, yeah, I can do that. Here, you're going to need my certificate. So it started when you initiated a secure connection to your bank via HTTPS. So once you did this, told the bank, hey, let's have a top secret conversation, the bank says, sure, no problem, here's my public key. Your computer is now in possession of the server's public key. Let me resize this a little bit so the screen doesn't get too crowded here. Say you're about to log into your bank. So you're going to send some login info to the bank. Now that's sensitive. If anybody gets this, they can log in as you. So before this login information is sent to the server, we're going to encrypt it. Now here's the thing about public and private keys. I've heard people abbreviate the methodology, and when they abbreviate it, they usually get it wrong. You'll hear people say, oh, the public key encrypts and the private key decrypts. And somebody else will say, no, you got that wrong, that's backwards. The truth of the matter is they can both encrypt, but whichever one you use to encrypt, you have to use the other one to decrypt. That's a key element here. Again, whichever key was used to encrypt, the other key has to be used to decrypt. So by sending the login information across the wire, encrypted using the server's public key as the encryption key, what would go across the wire would look like nonsense. In order to make any sense out of this, you would have to have the corresponding server's private key. So if it's encrypted with the server's public key, then to decrypt it, you have to have the server's private key, and hopefully the server's the only one who has that. But I'm actually lying to you, because it's not the login information that gets encrypted, because we would have a problem. We would have a problem in the very next step when the bank tried to send you your bank information. Because we could send something to the bank that only the bank could see because the bank has a key pair. But in this case, we do not. So there is no way for the bank to send us something that we can decrypt, but nobody else can. So what actually happens is before it sends the logon info, it actually generates a brand new random session key. Now this session key is a symmetrical key, meaning the same key is going to be used to encrypt and decrypt from this point on. But we need to get this key to the other machine. So before the key is sent, the key itself is encrypted. And it's encrypted using the server's public key. Remember, I'm sending it from this machine to the server. Right now, I have the server's public key, but I do not have the server's private key. Nobody should. That's why it's called a private key. So by using the server's public key to encrypt the session key, what goes across the wire, again, looks like complete nonsense. In order to make sense of it, you would have to have the corresponding private key. As long as it was encrypted with the server's public key, it could be decrypted with the server's private key. Now, both machines are in possession of the session key. That is how we can now have the rest of this conversation in an encrypted manner where nobody else can see it. So asymmetrical keys, you have to have them both. One of them is guarded very, very closely. That's the private key. The public key is handed out like crazy. But there's another element on here I need to emphasize, and that's this one here, the issuer. Who issued the certificate? I'm sure you've received a message going to a website that the certificate couldn't be trusted because it was issued by somebody you've never heard of before. Well, that's going to matter for us here too. So this application, we're going to generate a hash value so that we can tell if anybody modifies this. But we also have to have a private and a public key that belongs to the authority that's signing these documents for us, that's signing these applications. And this public and private key had to be given by somebody. It had to come from an issuer. We call machines that issue certificates certificate authorities. And here's the question. You can maintain your own certificate authority, or you could pay someone to send you a certificate. Somebody like, say, VeriSign. Why would you pay somebody? It depends on to whom you were going to hand the certificate. If you're handing it to one of your own machines, just make up your own. They're cheaper. You can do whatever you want. If you're going to hand it to somebody else and they're not part of your organization, you should buy one. But we're talking about how to protect applications. So it makes perfect sense in this environment to issue your own certificates. So what happens is the hash value that identifies this program is generated, but then the hash file itself is then encrypted. Encrypted using the issuers, or in this case, this is going to be the signer's public, or encrypted, I'm sorry, private key. So the hash value is encrypted with the signer's private key. That means the signer's public key has to be available to all PCs that you're going to do this to. Once you generate these certificates and issue them, the certificate that is attached, or rather the hash value that's attached, doesn't look like a regular hash value. It looks like more nonsense. But when it is decrypted, it decrypts to the correct hash value. So two things are actually being verified here. If I decrypt this and I get the correct value, then I know two things. I know, one, this application has not been modified, and two, it was signed by somebody I trusted. How do I know this? Because I used the signer's public key and it worked, which means it must have been encrypted with the signer's private key or it would not have worked. So I verified the integrity of the application and I verified the source of the signature that it came from. This is a big part of the requirements for rolling this out. You have to get these hash values, and using symmetrical and asymmetrical encryption, we're going to attach these hash values to the applications. If the hash value doesn't match the application, it means the application has been changed and it won't be run anymore. So to do this, you're going to have to build your certificate infrastructure or pay somebody else to get you certificates. Most people will just issue their own for this particular thing. That's what the package inspector tool is for. It allows us to take these legacy applications, some of which are very, very old and very, very important to your organization. For many of us, these are programs that there is no substitute for. We can't go to some other program because there isn't one. We can't go to the vendor and ask them to fix it because the vendor's been out of business for 10 years. If you have applications like this, these applications are inherently vulnerable to malicious code because there's no integrity checking of them anymore. Now we can do this. We can sign our legacy apps and our in-house applications too. I want to stress though that a signature is simply verifying the code. It is the code that you said you approved. It does not guarantee that it works. That is supposed to take place during your testing phase. You should not sign code until you've verified that it works. The signature is not verifying that it works. It's verifying that it's the code you said would work. So if you make changes to the application, you're going to have to update the signatures accordingly. So summary, what do we've got here? We've got consolidated methodologies. We can now use the same tools, Intune and group policies, to control desktops, tablets, and phones. This is finally putting control back in our hands for the applications that are running on our machines. In order to exert this kind of control, there's a fair amount of groundwork you have to do up front. You've got to get your certificate authority, you need to get a mobile device management, some group policies in place. But once these things are in place, I can have significant control over the behavior of this Windows 10 machine, all the way down to what programs it's allowed to run, depending on what user is using it, depending on where that user is, and depending on what time of day. I can use all of those as factors to control the behavior of a Windows 10 machine. Now, since this is a Windows 10 webinar, I wanted to spend a couple minutes showing you some of the things that are new to Windows 10 that will affect us. There are some really nice user layout things that have changed. The start menu is very different now. Instead of going full screen like it did on Windows 8, forcing you into tablet mode, I'm looking at these tiles now in desktop mode. It detects that I'm in desktop mode because I have a keyboard. If this was something like a Surface or a Lenovo Yoga and I could detach the keyboard, it would automatically go full screen with this start because now I'm on a tablet. I actually liked the tiles of the start screen, but I didn't like having to go full screen. So this is a great mix. You can have active tiles. These are the ones that are animated. Active tiles or live tiles involve communication outside. You can turn that communication off, making live tiles no longer live. They just become static. This makes them less interactive, but it also reduces the exposure of this machine. I can scroll using my mouse wheel here to scroll down, and you can customize the tiles. You can make them small, little itty bitty ones or larger ones. Some of them you're a little limited, like this one up here. This one has more options. That's largely up to the developer. The developer chose that they could have really big, wide, medium, or small. So you don't have complete control over them, but you have quite a few. There's also virtual desktops. Virtual desktops refers to what you see. Like right now I've got File Explorer open on my desktop. Maybe I also wanted to run the new highly secure Edge browser. Oh look, I'm looking for a job on monster.com. If you are working on several different projects at one time, you can switch. So here's a desktop with File Explorer on it. Here's the desktop with my web search. You can create additional desktops to keep different things you are working on at one time organized and clear. This is actually a security feature. Let's say I'm working on a payroll report, confidential payroll information, and somebody walks into my office and they need to discuss something else, something that requires my machine. Well, I can create a desktop that I can share with them that lets them see what they need to see, but not the things I don't want them to see. Notifications have been changed too. We see a really good mix here of what appears to be a tile-based interface and a desktop-based interface. So there's just a couple of little differences about the look and feel within the operating system. That's it for the security features for the new and evolving state that we're in. I now open the floor up to questions and answers. Brittany, are you out there?
I am. Thanks, Charlie. That was fantastic. I'm just going to show a couple of the Windows 10 classes that are being offered. And so let me share my screen so I can show you guys some of the...
Did we get any questions come up during the conference?
Didn't get any questions so far, but if anybody does have any questions, please feel free to type them in the message box, and then we'll go ahead and have Charlie answer those. So right now I'm sharing my screen. You all should be able to see it. It's our website. So if you're looking for any Windows 10 courses, you can either go up here where it says find a class and type in Windows 10. But then there's another way where you can go to courses and courses by vendor. Click on the Microsoft option. My computer's still thinking. There's a Microsoft option, but it looks like my computer is still trying to figure it out. And then you can go into the Windows 10. And here are the 3 courses that we are providing for right now, and then the upcoming dates. You just go to register, and you can see the outline what you will learn during the course, the description, audience, what you'll learn, and the outline. So you just go up to here for your location of where you want to take the course from. It could be from any one of the offices that we have, but it could also be from your home or office. That's our QS Live option. And click register, and you will be contacted by an account rep. There is also a phone number you can call, the 866 phone number at the top of the website. You can live chat us, you can contact us where you just fill out a form. And that will all come to us, and we can help you out with anything that, any questions that you have. We also have a couple promotions going on right now, and the 3 Windows 10 courses that you saw that we provide are part of this promotion, which is an iPad Air 2, a Surface 3, a $500 gift card, or you can have the option of doing a buy one, get 50% off, and then buy 2, get 1 free. So that's what we're offering right now. Otherwise, if there are any other questions, we have an info@quickstart.com email address that you can email, or if you know your account manager, go ahead and contact them directly on any Windows 10 courses that you are inquiring about or want to take or anything like that. So I'm going to open it up for any questions that there are out there. Go ahead and type it in the message box. Thank you, Amy. Yeah, and also I just want to let everybody know that this webinar was being recorded, so you'll be able to watch it again for any questions or anything that you have. If there are questions after this webinar has concluded, go ahead and email me, brittney.morin@quickstart.com, and I'll go ahead and get your question over to an account manager that can help you out, or Charlie. Okay, well, that will conclude today's webinar. Thank you, everybody.
Thank you, Brittany.